Today we're going to do another section. For now, go ahead and check your homework. Please just pause the screen so that you can look at all of them. And I'm going to keep moving it up, but if you pause the screen, you'll be able to see them. And remember, this right here, all this is a fancy notation way of saying that D is a number such that it's between -3 and 5. And that's all of them. Today, we're going to be doing kind of what we're doing. Basically talking about compound inequalities again, but instead of compound inequalities, we're going to be talking about not and, but or problems. And another word for or in geometry, we're going to talk about disjunction. Now, an or problem is going to be dealing in life when we use the word or. So if I say take out a pen or a pencil, you don't need both of them like you would if I said take out a pencil and a pen. Or would mean that if you had a pen but not a pencil, that'd be okay. If you had a pencil and not a pen, that would be okay too. And the big thing is you can have both. If you had a pen and a pen, or a pencil, and you had both of them, that would be okay. So or is going to show us that the answer is one or the other. It doesn't have to be both. You don't need both things to happen. So first of all, it's going to be easy to graph because you don't have to worry about where they intersect. You just literally graph both of them. So this is x is greater than -2 or x is less than -10. So if you think about that, you just graph them both. You could go right to the number line. X could be greater than -2. So let's say that's 0. Here's a -2. It could be greater than -2. So it's all this stuff. That's fine. Or x could be less than or equal to -10. So here's a -10. It could be a -10 or less than. Notice I'm not worried about where they intersect. It's literally just anywhere where they're shading. X could be anything over here, or it could be anything over here. X is greater than 1 or x is less than 10. That would look like this. It could be less than 10, so that's an open circle. Forever and ever that way. Or it could be greater than 1. Well, 1 would be right here. If it's greater than 1, I don't need to put an open circle because this 1 is already covered by the less than 10. So x could also be a 1. And then greater than 10, actually, it's going to cover all this. They're actually going to crisscross. So if you think about it, is there any number that's not greater than 1 or -10? I mean, 100. Does 100 meet one of these? Yeah, sure. 100 is greater than 10. What about -100? Yeah, -100 is less than 10. So really, this problem, if it would be all solutions, all real numbers, because there's no number that wouldn't work that would meet at least one of these two inequalities. All right. So the nice thing about or problems, inequalities, I don't know if you remember from yesterday, but a lot of times if it doesn't use the word and, but you see two less than signs, you know it's an and problem. With or problems, it's a lot easier because in order for, if you see two inequality signs, which if you notice right here, there's an inequality sign, and right here there's an inequality sign. If you notice there's two inequality signs, it's a compound inequality. And with or problems, it's going to actually use the word or. There's no notation that you're going to have like you had with and problems. So as soon as I see the word or, I know it's an or problem. And right here, we're going to solve each of these. So the first thing we're going to do is -1 divided by -1. Remember, you don't want to know what negative n is. You want to know what n is. And that's going to go ahead and leave us with n. But remember, we divided by negative numbers, so the sign flips. I'm going to write my or. And then over here, this is we're going to say that's 2n minus 3. So I'm going to add 3 to both sides. I'm left with 2n is greater than 8. I divide both sides by 2, and I'm left with n is greater than 4. So my answer would be this whole thing. N is greater than -2, or n would be greater than 4. So let's see what that looks like. And this would actually be your final answer. This is how you would write it. So you're going to notice in this case, you can simplify it a little bit. Because if n is greater than -2, it's going to be all this stuff over here. Now, if n is greater than 4, well, 4 is right here. We already have, the 4 is already taken care of, isn't it? Because isn't anything that's over 4 going to be the same as anything over -2? All this stuff's already covered, so I don't need to shade again. It's already shaded. So you could simplify this whole thing into just n is going to be greater than 2. Because if you look at your number line, that's what's shaded in. I'm sorry, negative is shaded in. And we're going to go through one more because they're actually easier than the and problems. So here's a number minus 1 is at most 9. So a number, we're going to call it x, minus 1 is at most. Remember, at most would mean less than or equal to 9. And then it uses the word or. 2 times that same number, we're going to use x, is at least, so that's greater than or equal to 24. So now it's a compound inequality, but it's an or problem. So we're going to solve them both. X is less than or equal to 10, or divide by 2, and you get x is greater than or equal to 12. And remember, now that it's an or problem, you're just going to graph both of them. Here's a 12 greater than 12 or equal to 12. Here is where the 10 would be, because the 0 would be down here. And it's less than or equal to 10, so we're going to graph this way. So remember, with or problems, you don't have to worry about where they intersect. This whole thing is neat. And that's how you solve or problems, or disjunctions.